Let's jump right into this explainer. Today, we're talking about building logical layers of defense to secure our enterprise networks. You know, when we talk about cybersecurity, people love to jump straight to the high-level, advanced, persistent threats. But today, we're focusing on the foundational architecture. Think of your network like a literal medieval fortress. You wouldn't just build one outer wall and call it a day, right? You'd want a moat, an inner courtyard, and of course, a heavily guarded throne room. Well, we're going to apply that exact same layered logic to your network devices.
But before we even start building those walls, we've got to ask a pretty critical question about the very devices standing guard over our data. I mean, what happens if an attacker doesn't even bother trying to break through your firewall and instead just logs right into the router that controls it? If our infrastructure devices, the routers, the switches, are compromised, the whole security posture just totally collapses. The guards themselves actually become the vulnerability.
We always picture hardware and server racks, right? Tangles of cables, blinking lights, and some locked-down, climate-controlled room. But physical security? That's really only half the battle. These critical physical devices are completely exposed if we don't lock down their command line interfaces. Seriously, an attacker sitting halfway across the globe doesn't need a physical key to your server room if they can just SSH straight into your core switch, all because of a weak password policy.
So here's our roadmap for this explainer. 1. Locking down passwords. 2. The power of hashes. 3. Blocking attacks with ACLs. 4. Firewalls and security zones. 5. Intrusion prevention systems. And finally, next-generation defenses. Let's get into it.
Section 1. Locking down device passwords. Securing the throne room.
We're starting right at the heart of the device, the command line interface. This is our throne room, and whoever holds the keys here literally controls the entire device. Now, this is the ultimate do this, not that for networking. On the left, we've got the super outdated enable password command. In the early days of Cisco iOS, sure, this was the standard, but it stores the password in the config file as vulnerable clear text. Anyone doing a little shoulder surfing or anyone who grabs a config backup can just read it. On the right is what we actually want. Abandon that old command and always use the enable secret command. Instead of saving the raw password, this computes and stores a highly secure hash.
Now, you might be wondering, hey, can't I just encrypt those older clear text passwords? And yeah, technically there is a command for that, service password encryption. But honestly, it gives a really dangerous false sense of security. While older iOS versions offered this, the algorithm is notoriously weak. We're talking attackers cracking these in literally seconds using free websites. Because it's so easily broken, we absolutely must rely on hashing instead.
Moving on to Section 2. The power of hashes. Making secrets truly secret.
So the real magic here is that a hash is a one-way mathematical function. Unlike encryption, which is meant to be reversed if you have the right key, a hash takes your password, scrambles it up mathematically, and it literally cannot be unscrambled. When you log in, the device just hashes your input and checks if it matches the stored version. To stay ahead of the bad guys, Cisco has continuously leveled up these enable secret hashes. Originally, iOS used type 5, which is an MD5 hash. Better than clear text? For sure, but modern computers can brute force MD5 at terrifying speeds. So modern iOS moved to way stronger algorithms, introducing Type 8 using SHA-256, and even Type 9, which uses the highly advanced script algorithm.
So what happens out in the wild if an engineer accidentally leaves that old clear text command in the config right alongside the new secure one? Well, luckily, the device is smart enough to protect itself. If you somehow have both commands sitting there in your configuration, iOS automatically overrides the weaker one. It will strictly demand that hashed secret when anyone tries to hit privileged mode.
Of course, in the real world, we don't just use one master password, right? We have individual administrator accounts. And the good news is we can apply these exact same powerful hashes to any local user accounts we create on the device. By using the username secret command instead of the old username password, we lock down that individual access using those same robust Type 5, 8, or 9 algorithms. This keeps our config files totally pristine and safe from prying eyes.
Section 3. Blocking attacks with ACLs. Defending the inner courtyard. Okay, so our throne room is locked tight. Now let's move out to the inner courtyard and stop attackers before they even reach the door. If the password is the lock on the door, we need a gatekeeper to keep bad actors off the property entirely. That's exactly where access control lists, or ACLs, come in. When an external user tries to connect remotely via Telnet or SSH using a virtual terminal or VTY line,
We apply an ACL to act as our automated bouncer. Malicious IPs are completely dropped before they can even try to brute force a password. If an attacker's IP isn't on the VIP list, no way. They don't even get the courtesy of a login prompt. Their traffic is just gone.
Which brings us to Section 4, Firewalls and Security Zones, building the outer walls.
Let's zoom out to the network perimeter, right where we build our massive outer fortress walls using traditional firewalls. We've secured the devices, but now we've got to secure all that traffic flowing through the enterprise. A firewall is basically your ultimate border checkpoint. It's a purpose-built security appliance sitting right at the edge of your network, constantly monitoring data in transit. It checks those packets against a strict set of rules you've set up and decides who gets in and who doesn't. If the traffic doesn't pass the check, the firewall just drops it, stopping the attack dead in its tracks before it even enters the network. To keep all these rules manageable, firewalls use something called security zones. By carving up our network into distinct areas, we apply really strict policies about who can talk to who. Like your internal network, that's a trusted zone. The open internet, completely untrusted. And we brilliantly use a DMZ, a demilitarized zone, for public-facing servers, like your company's web server. The internet can reach the DMZ, but if a server in there gets compromised, the attacker still can't cross over into your trusted internal network.
Section 5. Intrusion Prevention Systems. The Active Guards.
Here's the thing, though. Walls alone just aren't enough. If a threat disguises itself as normal, permitted traffic, your firewall is going to wave it right through. That is exactly why an intrusion prevention system, or IPS, is an absolute must-have. While the firewall is checking basic rules like IP addresses and ports, an IPS is inspecting the actual behavior of the traffic. It's comparing complex patterns against this massive, constantly updated database of known attack signatures. If it spots a nasty exploit hiding inside seemingly innocent web traffic, the IPS actively jumps in and kills the threat in real time.
Finally, Section 6. Next-Generation Network Defenses, Upgrading the Modern Fortress.
As we all know, the security landscape is just an endless cycle of new attacks and new defenses, which means our perimeter tools have to evolve dramatically. Today, we're heavily relying on Cisco next-generation firewalls and next-generation IPS. These are a massive leap beyond basic signatures. We're talking features like application visibility and control, meaning they don't just see web traffic, they know exactly which specific apps are running. They do deep URL filtering, they monitor contextual data about vulnerabilities on your specific network, and crucially, they hunt down zero-day threats. And this is all powered by continuous real-time updates from global researchers like Cisco Talos Intelligence, so your tools are always working together intelligently.
So I want to leave you with this question to chew on for your own enterprise. Are you building a modern layered fortress, or are your guards basically asleep at the gate with the keys out in plain sight? We've covered a ton today, from enforcing those strong script hashes on the CLI to dropping unauthorized IPs with VTY ACLs, all the way up to deploying next-gen, threat-aware perimeter defenses. In a world where attacks are automated and absolutely relentless, relying on outdated tech is just an open invitation. So take a look at your architecture. How many layers is your network missing?